Hi guys, this video today is going to cover multiplying and factoring with the greatest common factor. And so this is hopefully going to be some review for you. We're just going to review some rules of how you multiply and how you factor some basic factoring. The first thing is with multiplying. When we multiply, we do distribution, and we're going to multiply that negative 6m to the fifth multiplied by all three terms inside. And when we do that, a lot of people can't remember what we do with the exponents in that case. In that case, we would add those exponents to be negative 12m to the ninth, and then we have a minus there, and we have an 18m to the seventh, and a plus on the end, and it is 12m to the fifth. So that's just a basic review of how you do that. The next problem is very similar. It's just that at the end, we're distributing, kind of looks like backwards. It's really just normal distributing, but it's just kind of out of order how we normally see it. But that does happen, so we do need to take some time to make sure we understand that. So our first multiplying, when we do this, we're going to have 5p to the fourth plus 2p squared. Now, when you have a minus in between there, make sure that you're basically distributing that minus sign. So one thing you could do is put this inside parentheses to start, and that would be 7p squared minus 28p. But now we need to distribute that minus sign. And what I mean by that is you're going to keep these first two the way they were. But then you're going to take this minus sign, and what this really means is because there's parentheses, you are subtracting the 7p squared, and then minus negative means you're adding the 28p. And then lastly, we would want to add any like terms. And by like terms, I mean things that have the same exponent on them. So the only things that have the same exponent on them are these two middle terms. I'm running out of space, so I'm going to come down here a little bit. And so I'm going to keep my 5p to the fourth the way it is, but my 7p to the second and 2p to the second, I'm going to combine those for a minus 5p to the second and plus 28p. So that is how we do distribution. And anytime we distribute, if we have like terms, we need to add our like terms together. Okay. The next part is on factoring, and it's GCF factoring. One thing you need to know is that factoring is the opposite of distributing. So if you're not sure what factoring means, it just means distributing backwards. So take a second and look at 1 through 5 here and see which ones match up. So see if you can match these up on your own. And the idea on this matching is you don't have to go through and multiply out every single one. You should be able to look at some general trends that are happening and kind of pick up on some things. For instance, if you look at A compared to B, the differences, you can see some differences. On A, it only has 2 terms, and on B, it has 3 terms. And when I talk about the terms, I'm talking about the ones inside there, because eventually you're going to multiply it and it would still just be 2 terms, or this one would still just be 3 terms after you multiply it. So that's one thing. So like for instance, letter B and letter E are the only trinomials. So they have to match with 3 and 4 because those are the only trinomial answers. Another thing that you could be looking at is, do we have just x's or do we have x's and y's? And so that's something to consider. And finally, you might also look at the highest degree. So for instance, maybe I'll just pick the trickiest one to look at is B. I have x to the second here, and if I multiplied that, I would get an x to the fourth. And as I look at all the other answers, none of them have x to the fourth in them. So that's something else that you could look at, is whatever that term is. So this is a matching exercise, but it's demonstrating factoring. So let's just move on to the factoring portion of it. So as I said a minute ago, factoring basically reverses the multiplication process. So in order to factor out a monomial from a polynomial, you have to find the GCF, the greatest common factor. So if we look at example number 1, can you find what the GCF would be? So hopefully you can see that the GCF would be 5. And then what we're going to do is we're going to divide each term, divide by 5. And so when we write our answer, we're going to have our 5 on the outside, and then we're dividing each of these. So that's going to be 3x squared plus 2x plus 5. And so this is the factored version of this. I had to take out my common factor, which was 5. That's number 1. If you look at number 2, it's going a little bit more complex. So in number 2, we're still looking for the GCF, but the GCF is going to have a constant, that's a number, and an x, and a y. So let's talk about that. So for the constant, the number that we could divide out of all of them would be 4, right? 4 goes into each of those. For the x's, we're looking at what is the highest x that would go in to each of the other x's. And basically to do that, you're looking at which one has the lowest exponent on it. And so here is an x to the first. So x to the first, or just x, is part of my GCF. How about my y's? Well, again, I look for the greatest y that could go into all of them, which basically means you're looking at the y with the lowest exponent. So that's going to be y squared. So I'm going to be dividing each of these terms by 4xy squared. And so when I do that, we have to go back to our exponent rules, and that is for the exponents, one of these x's would cancel with one of those x's and would leave me with an x squared. The 4 and the 4 are going to cancel all together, and 2 of these y's are going to cancel with 2 of these y's, and that's going to leave me with a y squared. The shortcut way to think about that is you're subtracting. So the exponents you're subtracting, the big numbers you're dividing. And so our second term, 12 divided by 4 is 3, and I have a minus sign between here. My x's is just an x, because 2 minus 1 is 1. And my y's is just a y. And I'm running out of space here, but I'm going to try to scrunch it in down here. 24 divided by 4, there's a minus, and it's a 6. The x's, those x's totally cancel out, and those y's totally cancel out. So it's just minus 6. And so I have my GCF on the outside, and then I have my 3 terms on the inside. That is how to factor with the GCF. We'll do some more practice on that. So before we go on to the next section, if there's any questions you have, please write down your questions, bring your questions to class. Because this next section is on special cases. And we the other day talked about multiplying binomials, and we also talked about multiplying binomials when it's a perfect square. I want to get back to that, but I want to show you these rules. And these are, I'm not usually a proponent of memorizing, but in this case, if you can memorize these, it's going to make your job a lot easier. Because let me show you. Okay, the way we were kind of doing it the other day, and it is fine, is we would multiply that out, and then we would multiply this, and then we would combine our like terms, and we get we get x squared plus 10x plus 25. That didn't take a long time, but it did take some time. And then to add to this discussion, if you're doing the box method, that's taking even more time. And I've mentioned this, that sometimes you want to save some time in these problems. And so, yes, this is fine. There's nothing wrong with this. And honestly, I do this a lot. But if you can remember the rule, it's going to make it a little bit quicker. So let me explain that rule for you. This rule, it's the top one here, and the rule says you just have to square the first term. So in this case, it'd be x squared. You have to take 2 times a times b, so that's 2 times x times 5. Well, 2 times x times 5 is 10x. And then you put on the end the b squared, and that's 25. It gets the same answer, but it's just a little bit shorter. And so if you can remember the rule, it'll make your life easier. Let's look at the next example. Okay, once again, you could take this 2x squared minus 3 and you could multiply it times itself. That's fine. But let's try to use the rule and see if we can do that. So I'm supposed to square according to my rule, and this is now the second rule because there's a minus, but it's very, very similar. Look how close those are. So we're going to take the first term and square it. So my first term is 2x squared. I'm going to square that, which gives me 4x to the 4th. My middle term has a minus, and then 2 times a times b. So I'm going to put my minus 2 times 2 times 3 is 12. And then we have our x squared. And then the last term is plus 9 because we take the 3 and we square it. So if this rule works for you, it's a time saver. If it doesn't and you still want to do it the long way, that's fine. Do it the long way. Again, I'm not a big proponent of memorizing, so if it's just too much to memorize, don't worry about it. There's another one that is another special case called the difference of squares. And that is, notice the two terms are very similar. The only difference is we have a minus and a plus. So once again, I'm going to start off by showing you kind of the long way, which works, it's fine. But we would get x squared plus 3x minus 3x minus 9. We add those middle terms together because they are like terms, and they cancel out, and we get x squared minus 9. That works. There's nothing wrong with it. The shortcut says we can do it shorter, and so that's listed over here. It basically says you just have to square the x and square the 3, and you get your answer. You put a minus in between them. So a little bit shorter. Let's take a look at number 8, doing it the short way with the memorizing the rule. So the rule says just square the first term. The same one here is the same one here, and so that's 9x to the 4th. Then you put a minus between them, and then you square the b term, which is 1 or negative 1, doesn't matter, they're both a b. So that's just 1. And so that's the final answer. And that's it. Okay, this page honestly was a lot of review. So some things that you might write down in the summary, you might write down that when you're multiplying power or exponents, you add, well, when you're multiplying powers, you add the exponents. You might write down to remember to add like terms when you're doing that. So take a few seconds to write down a couple things. There's not a whole lot to write in here, but write some stuff down about what we learned today. And then we'll do a little bit of practice, not a lot, but we'll do a little bit of practice in class. And I'm saying not a lot because the next 2 pages of this handout actually have a lot of practice for you.